So what are the Collinear points in the inner space, and how can you be able to show whether the points are Collinear or not in a space? Now let's say we have a point. Let's say this is a point A, and we have, let's say, a point, let's say, giving us the point B. And let's say we have another point, let's say this is the point C. And assuming that the points are connected, let's say assuming that the points are connected by a straight line in this case. So now if this is the case, then we say that the points A, B, as well as C are Collinear points because they lie on the same straight line. So that's about the Collinear points. So these are the points that lies on the same straight line. So that is. So now without having the actual sketch, how can you be able to know whether the actually given points are Collinear or not? In other words, how can you be able to actually determine whether the given points actually lies on the same straight line or not, if that's the case? So now for instance, let's say we have a point A within actually in the space, that is in a three-dimensional coordinate system. And let's say a point consists of the coordinates given us now should be x1, y1, and also z1. Let's say that's the case. Let's say this is the point, by the way. And let's say we have, let's say, another point giving us the point B, and that should be within the same actually a three-dimensional coordinate system. Let's say this one is having the coordinates given as x2, y2, as well as the z2. Let's say that's the case. And we have another point. Let's say this is a point C. That should be a point C. And I say it is having the coordinates, let's say, giving us x3, y3, as well as the z3 in that way. And now assuming that the points are connected by the same straight line in this case, let's say that's the case. So now as it stands here, it means it means the points are said to be the Collinear points. So how can you be able to determine whether the points are Collinear or not without having that kind of actual sketch? So now here is the way to go. Actually x1 minus x2, and that divided by should be x3. It should be x2 rather. Should be x2 minus x3. It has to be equal to, now should be y1 minus y2 divided by should be y2 minus y3. That should be equal to z1 minus z2 divided by z3. Should be z2 minus z3. So now, which means the rate at which the x changes from, let's say, a point A to point B should also be the same from the point B to the point C, and likewise for the y as well as the same. So now this is the condition that satisfies actually the points to be Collinear, and that is inner space. So which means x1 minus x2 divided by x2 minus x3 has to be equal to this one and also this one. So that's how you can have to determine whether the points are Collinear or not, that is inner space. And for instance, let's say we have the following points, and we should have to show whether the points are collinear or not. And let's say we have should be a point A with coordinates given as 2, 4, 2, and let's say we have a point B with coordinates, let's say a 3, 7, and let's say -2. Let's say that's the case. And we have a point C with coordinates given as 1, 3, and also we have a 3 here. So now, how can you be able to show whether the 3 points are collinear or not? So in this case, you should have to understand that actually we have x1 that is given as 2, and y1 we have it as 4, and z1 we have it as 2, and we have x2 that is given as, it should be 3, and y2 we have it as 7, and we have z2 that will be given as -2. That is that one. And of course, the point A will correspond to the first coordinates, that is x1, y1, as well as this one, and the point B will correspond to the second coordinates. And likewise, x3 will have it as 1, and y3 will have it as, that should be 3, and the z3 will have it as a 3 as well. So that is, so what is the formula we should have to use? So now, if these points are said to be collinear, then this should be true. So in this case, we can have it as x2, so it should be x1 minus x2. So it should be x1 minus x2, and I divide by x2 minus x3 has to be equal to y1 minus y2, and I divide by y2 minus y3, in that case, and the z1 minus z2, and I divide by z2 minus z3. So now we just have to substitute the values that we have into the formula. So in this case, we'll have it as, what is the x1? We have it as 2, and the minus, what is x2? We have it as a 3, and I divide by x2, which is 3, minus x3, and which is 1, and which is equal to, now what is y1? We have it as 4 minus y2, which is 7, divide by 7 minus y3, which is 3, that which is now being given us. So that is, what is 1? We have it as 2 minus z2, which is given us now -2, and I divide by -2, and that should be a minus z3, that which is given us now should be 3. So now, for instance, you can see that the points are no longer collinear because the condition is not being satisfied. In this case, we'll have -1 over should be 2. You know, this is not equal to, now in this case we'll have it as -3, and over 5, and which is also not equal to, we'll have it as 4 over -5. Hence the points are no longer collinear, since that's the outcome. So the points are no longer collinear in that way. Now, so let's try to go over this one. And how about if we have this case? Let's say we have a point D with coordinates given as 0, -5, and a +5, and we have a point E with coordinates given as 1, -2, let's say a 4, and we have a point F with coordinates given as a 3 and a 4, as well as the 2. So how can you be able to show whether these points are collinear or not, and are using the same principle? So in this case we'll have it as, and should be, we have x1 that is given as 0, and we have y1 that is given as the -5, and the z1 is given as the +5, and we have x2 that is given as the 1, and y2 we have it as, and should be -2, and as z2 we have it as, no, should be 4, and we have a z1 that is no, should be, we have z1 that is being given as, no, should be 3. So what's going on here? And by the way, we have x1 given as y1 and as well as the z1 that is, and we have x2 given as this, and y2 given as this, and z2 given as that. So now which means we'll have x3 here, x3 given as 3, and y3 that is given as 4, and that is a z3 will have it as 2. So that's the principle behind. So in this case we'll have it as x1 minus x2 over x2 minus x3, that which is equal to, now y1 minus y2 over y2 minus y3, that which is to be equal to z1 minus z2, and that divided by z2 minus should be z3. Let's see if that will be the case. So now we can have it as, what is x1? We'll have it as 0 in the minus, what is x2? We'll have it as minus 1 divided by the 1 minus the x3 is given as 3, and that should be equal to y1 we have it as -5, and that should be minus, what is the y2? We'll have it as, and that should be negative, should be 2, and that divided by should be, what is the y2? Have it as -2 minus y3 will have it as a 4. So now which is equal to, and we have z1 that is being given as, that should be 5 minus z2 which is given as 4, and that divided by, that is of, should be 4 minus z3 which is given as 2. So now as you can see, now in this case we can have it as -1 of should be -2, that which is equal to, now we'll have it as -3 over -6, that which is equal to 1 over 2, and of course upon having the further simplifications we'll have it as 1 over 2 which is equal to 1 over 2, that which is 1 over 2. Hence the points are said to be the collinear. As you can see, the condition actually has been made. So that's the principle behind. Thank you.